Okay, good morning again. Thank you for joining this webinar today, jointly organized by EGEC in cooperation with our German partners, BVEG and DGMK. We have several topics to discuss today. First, we will present you the risk management during the drilling and testing of deep geothermal, and see how such guidelines can be replicated as a best practice for other countries. So, why I mention that is because indeed we see that we need to simplify permitting. It's a topic discussed everywhere in Europe, but there are several ways of simplifying the permitting. Changing mining law, changing environmental law, changing environmental impact assessment, but also adopting new standards, codes, guidelines, best practices can simplify a lot of project development. And also have more successful projects. More successful project. Many people all the time associate geothermal with risky, but we are much less risky than oil and gas drilling. Let's see what think our colleagues from BVEG. I will present you shortly the agenda. First, I will just introduce you the topic of today and some first thinking. Then I will give the floor to Ingo Forstner and Nicole Grovys to present the publication in December 2025 of these guidelines for Germany and deep geothermal projects in Germany, how they can benefit from this structured approach. To have a detailed overview of the guidelines, we give the floor to Sebastian Homuth from Deutsche ErdWärme. Once we have here from Germany, it will be interesting for us and for all of you to hear what has been done in France. And Virginie Hamm will present a guide that was published some years ago and they have updated recently. From Frank Maartense, we will hear a lot of developments in Netherlands. They have been one of the first now in developing new guide for wells integrity. So let's hear from her. And from Gregor Gotzl. In Austria, we see also new development of standards and approach on developing geothermal. So let's hear also from Gregor what is happening in Austria. We'll have a discussion between also these panelists, and then we will open the floor to the audience. We can see already more than 250 people attending. We have nearly 500 people registered, so a lot of interest about this topic, and we are really glad to offer you this opportunity to have this presentation and this discussion today. Indeed, the topic is mainly on deep geothermal. When we say deep geothermal, there's not a strict definition, but we speak mainly of projects where need wells going to deep depths. The topic of having guidelines for drilling is not new. As I mentioned, some countries have already done that. Good to hear the reasoning why in Germany we have decided to develop these new guidelines and what the industry, the market actors are thinking about such a new guide. It's important that today we need to develop more geothermal projects all over Europe, and we need to have this best practice shared. We ask on behalf of EGEC and all the European stakeholders in geothermal the establishment by the European Commission urgently of a geothermal alliance. What is an alliance? It's this platform that will allow all of us to share these best practices. We offer you today in a webinar with EGEC, but we all agree that it will be even better to meet regularly, to have a permitting agencies, to have energy agencies, to have a range of ministry meeting with us to allow to simplify all these rules and to share these best practices. So hopefully today we will share good news, but it's not the end of the story. It's just a start of a nice story to have much more geothermal in the future. I close with that my introduction, and I immediately give the floor first to Ingo Forstner, the head of storage and geothermal at BVEG, to present a bit more approach of this new guide released in December 2025. Ingo, the floor is yours.
Many thanks, Philippe, and thanks for a really good introduction. I think that's a good point. Best practice is key, and we're going to see that today, I think. Great to have you all here. I think it's a really important topic, as I said, and it's also a very timely topic, at least for Germany, and I hope it's the same in your places, because at least in Germany, it looks like we're going to have growth ahead, because just for Christmas, boundary conditions have improved quite a bit. There's been 3 new initiatives by the German government that all come into place now. One is a streamlining licensing law, basically for mining laws, water law, and such, specifically for geothermal. Another one is a risk insurance, a geological risk insurance that we didn't have for a long time, that's now available. And the third one is a new development program, primarily for greenfields, with the aim of 10 terawatt hours, which is quite a bit, I think. So let's go, right? So we're excited. We've got a lot of things that fell into place. Let's do it. But doing it means, since it's such a big task, we're probably going to have many first timers. We are probably going to have many people who haven't done that often or not at all. And that means we have a need not to reinvent the wheel. Yeah. And not reinventing the wheel means using standards, for example. Standards make it more efficient, yeah, and we are a cost-conscious industry. Yeah, it's important. And standards make it also safer and also environmentally safer. And we're dealing with large masses during drilling and everything, pressures and all. So that's also very important. And generally, if you do a structured approach, if it's with standards or your own management system or so, yeah, that allows for a learning curve. And learning curves are important, especially in a geological setting that we have. And also especially in a setting where you have true interdisciplinary interdependence, yeah, and need to have this communication. And Philippe, you mentioned oil and gas. We're not oil and gas, yeah, but there are actually quite a few things that we have in common. There's also things where we differ. One thing what we don't have in common is we are younger. Well, kind of, at least in size, yeah. I know our Italian friends will talk about it differently, but oil and gas has been around for like 150 years. And when it came to structured approaches and such, they honed that for 150 years. And they do this. And why do the companies do it today? Because those who didn't don't exist anymore. Yeah, it's important. Yeah, and that may be even more important for deep geothermal because we've got a more fragmented, smaller entity environment, often one plant players or so. So there's probably even greater need for like partnerships, for pooling resources, for not starting a learning curve from scratch. Yeah. And if you talk partnerships, that even makes more sense, or it makes even more sense if you have a structured approach and how you communicate, how do you do things. Yeah. And because structure is so important, as BVEG, we have created and maintained several technical standards for Germany. Anything with deep wells. In the beginning was mostly oil and gas, but it's basically applicable, most of that to anything that's got to do with drilling or deep wells or so. Something like wellbore integrity, drill pad design, things like that. Yeah. But recently we have pooled with DGMK, Nicole, and several experts like Sebastian to write some specific standards for deep geothermal. And because there's some specifics, and especially when it comes to structure, when it comes to management processes, etc., I think there's a great need. And yeah, and I'm glad we could pool with DGMK, and that's why handing it over to Nicole now.
Yeah, thank you very much, Ingo. I do actually have 2 slides to show. Hope that works for you. Yeah, these are the guidelines we created together with BVEG. It's a bit uncommon for me to pronounce that in English. And both of them are published already. The economic assessment of geological risks of deep geothermal projects was published already in 2024, and this is already used commonly in the German geothermal industry, and now very freshly published, and that's why we are here, is the risk management during the drilling and testing phase of deep geothermal projects. And I'm very, very happy that we could do this together with the BVEG. And the idea came from the DGMK working group Geothermal, where Sebastian is part of it. And we had a big group which was involved in creating these guidelines. And together with BVEG, we went into detailed public consulting process and made the official publication within the industry association of BVEG. So authors came from industry associations, geothermal companies, service companies, scientific association, that's more or less us. DGMK is a scientific association, project developers, insurances, and also E&P companies. As Ingo said, there is a lot of knowledge which we can use and make geothermal projects safer, more structured, and more efficient. And that's basically the aim of these guidelines. The target groups are all institutions and individuals who are involved in the planning and development of deep geothermal energy. And as I said, there are many authors of the guidelines, but we have one here in the webinar, and this is Dr. Sebastian Homuth. He works for Deutsche ErdWärme GmbH and he's head of operations. And he has a long history in geothermal energy. And we're very happy that he will now present the guideline. And we would also like to thank all who contributed to the guideline and everybody who commented to the guideline. And we are very happy that we as DGMK and BVEG have these 2 guidelines which are widely used in the German industry, and we are working on a 3rd one which you will see in end of the year or so. Okay, let's now hand over to Sebastian Homuth. I'm still sharing. Wait. Yes.
Yeah, thank you, Philip, Ingo, and Nicole for the great introduction, because that took away all my introduction, which is great. And then we can directly jump into the topic. Let me quickly share my screen. So I hope you see the screen now. It should be working. Yeah. So as Nicole already mentioned, this is actually a 2-part guideline that is out there now. For the first part that deals more with the geological risks, have already been published in December 2024. And we are now mainly talking about the second part of those two-part guidelines, the risk management during the drilling and execution phase, basically. But I want to stress here that both guidelines are deeply interconnected. They have a strong dependence on each other. Because Ingo mentioned it already, there's a great interdisciplinary approach that needs to be reflected also in the overall risk assessment of any subsurface project, basically, but specifically also for the geothermal project. So as we heard about all the organizational parts, that's already done. Just want to emphasize that if you want to have a direct link to those guidelines, there's the QR code here in this presentation, which you can basically just use to go to the source and have a look directly in those guidelines. Before we jump into the second guideline, the risk assessment for the execution phase, I want to basically give a little bit more broader context on what was the thinking behind those guidelines. So we all know that there is a big interest in geothermal at the moment, and it's keeping growing all over Europe for sure, but also worldwide. But focusing on Europe here, we definitely want to see a strong ramp up of deep geothermal energy projects, and we see a lot of efforts from governments, from institutional investors, from utilities, municipalities that are looking into geothermal. And we have some roadmaps and ideas about how the future of geothermal can look like, and it's quite ambitious. And as Ingo pointed out already, we will see a lot of new players in the field of geothermal energy, and we've seen also requests from the industry itself, but also from associated industries like the insurance market and investors that are also new to the field, that there needs to be a planned, structured approach on how to deal with risks that are associated with geothermal systems. And why is that? Because we want to effectively allocate the investments and the subsidies that are available. We want to increase obviously the success of these projects and commercial output. And we might also need insurance schemes for dealing with those risks, especially when we are having developers that might not be so used to deal with these subsurface risks and drilling risks. So these are all factors that are quite important to have in mind when we're thinking about standardization and guidelines that help to de-risk projects. Just a quick word, where is this applicable? Obviously, those guidelines are applicable to all known geothermal systems. We are typically talking about deep systems here, not so much about, or definitely not about the shallow geothermal applications that we see that are implemented in the first 100 meters or so of the subsurface. That's a different topic. We are dealing here with deep wells, typically of a couple hundred to a couple kilometers depth, standard commercialized hydrothermal systems, or also closed loop systems can be part of that assessment. Petrothermal systems, enhanced geothermal systems, and obviously all systems that in the end just depend on the temperature and the flow rate regime in terms of what you get out of those systems, if it's electricity production or heat production. But that's basically the applicable framework. What are the challenges and concepts that we have to have in mind? As I mentioned already, we need a structured approach through all different project phases in the planning and execution part of geothermal projects, and that is here interconnected from the geological risk perspective, but obviously also from the drilling risk perspective, and how do we deal with the associated uncertainties, and how do we can translate this into the overall project economics. So we need a kind of a multi-step approach to deal with those challenges on how to mitigate risks and deal with risks, and especially in the geothermal world, was also already mentioned, we have a certain cost pressure. We are not in the luxury position like we might have it in oil and gas fields somewhere where 1 or 2 wells not working so great. The rest of the field will compensate for that. That is typically not the case in geothermal, unless you have really big drilling campaigns ahead of you. Then it might be the same, but typically that's not established yet. So we need a multi-step approach to deal with these pre-drilling and drilling risks that are associated with those projects. And the first 2 or 3 points that we see here, basically the quantification of the geological probability of success and how we deal with the variability of potential geological scenarios. That is part of the first part of the guideline. We are now focusing more on the second part, on the drilling risks and the technical risks, and what kind of tools can we use to deal with those risks. And then in the end, obviously, there also needs to be continuous risk assessment also for the operation and long-term production phase, but that is currently not covered in those guidelines. Just want to quickly go to this overview here as well. As I said, the first phases of geothermal projects are covered in the first part of the guideline, where we typically deal with the geological framework and the typical subsurface data evaluation. And before we enter actually the phase 2 and go into certain data acquisition, we need to know what kind of data we have available to us from a geological, but also from a drilling perspective. And before we go into phase 3 of this, what we call a stage gate process, basically we also need to assess all the technical risks that are associated with the drilling execution and the well engineering. And that I will focus on in a couple minutes. And this is part of the second part of this guideline that is now newly published since December 2025. What I also want to mention, and what Nicole already introduced as well, is that there is certainly, or it is a good recommendation and a good industry practice to have peer reviews on all of these stages before you enter the next phase of the project. And this is part of a next guideline that we're currently working on to how peer review is structured and what is important to do when we do good peer reviews. So there will be coming more, as already mentioned, most likely sometime this year, depending a little bit on how productive we are. But let's start with deep dive into that second part of the guideline here. First, we need to have a view on what kind of data we have available. This is just a simple example from the southwest of Germany in the Upper Rhine Valley, where I currently work in. And we see areas where we have a lot of data, but we also see other areas where we might not have this data density. And then especially when we are thinking about offset well data and well engineering approaches, what is important, it is the lessons learned and all the information that we have available from surrounding developments. And typically, when we go into geothermal developments, in most areas we don't have that intense data that we would like to have, like we have it in a lot of oil and gas fields, for instance. And that's why we end up with projects that have a high complexity associated with data poor area, which obviously then translates into higher risks. And those risks need to be properly managed. And how can we do this? We start with assessing the available data and see if that is sufficient, or do we need to address this with additional data acquisition. And why are we doing this? Because this is the basis for all that comes afterwards. So only if we have an adequate definition of our subsurface models, or only if we have geomechanical data that is also important for the well engineering process and the execution of the project, if we have that data available, we can significantly de-risk the execution phase and the later important processes. So what is important input data is subsurface models. It's in some areas for sure is also seismic hazard studies that are very important. We need the correlation of different borehole data offset well data analysis, see what kind of well engineering and design approaches have worked, have not worked in this area, what's the reason for that, and implement all those lessons learned into that process. And the only way how to do this is basically via a proper risk assessment, and then also have the justifiable base on deciding on these issues. So that is part of the de-risking process in the risk assessment, and it can lead into both ways. We can either go from one stage to the other and saying, okay, we have ticked the boxes, this is great, it works for this area, or we can also prevent potential failures. If we say, well, in this area we simply do not have enough data, we need to go back to the drawing board and see if we can do something about it, or even the project cannot proceed because it is associated with too high risk. And this is also then coming back to the initial motivation, the proper allocation of funds. Is it good to invest in an area where we basically have not done our homework, or we have not sufficient data available, or the data basically suggests that here the probability of success is so low, combined with the technical execution risk, that it might not be good to have a project there. But having that those processes in the background enables also further financing steps or insurability of projects, because we can, with a proper risk assessment and a proper preparation of documents, we can enter or enable basically insurance programs to come in, additional companies that are interested in sharing the risk via joint venture structures, and so on. So that is an important tool to have a sensible investment and funding decision for the geothermal project. So now dive deeper into the drilling and execution phase of the geothermal project. Also here we suggest to have a stage gate process in the well delivery process, like you have it in the geological analysis as well. You start at a concept and drafting idea, basically with a lot of options, and then also here, when you go from stage to stage, you will need to review the data that is available, the concepts that are dealing with the specific project circumstances, and then you are able to shift basically the decision making also to an interdisciplinary team, because it's always good to step out of the engineering bubble or the geology department bubble, and have a good interconnection with those teams, so that you have a good overview of the risks that are sometimes associated also with the interdisciplinary part of things. This is a continuous process. It doesn't stop with the first well. It needs to be obviously implemented throughout the whole drilling campaign, because only when you have implemented the learning from the first well, the second well will hopefully see less issues or no issues, and it is a good overall tool to decrease the overall risk structure. So from this continuous learning curve that moves from the individual know-how of certain consultants or of certain departments, is basically a translation into the organization-wide learning curve. So what are the tools in this risk management cycle that we have integrated? A lot of standard tools that you know from all sorts of risk assessment or risk analysis. First, you need to identify the risks that you have, and you should do that always in an interdisciplinary team, so that you can show light on certain issues from different angles. You need to analyze and evaluate those identified risks, and there is a whole toolbox suggested in the guideline, going over SWOT analysis, where you identify strengths and weaknesses of the approach that you are discussing in the project. Bow tie analysis, where you come from hazards and the consequences and narrow it down to certain options. And when you have done this, and obviously there are more tools available than only those two, I just picked out these two, then you have put this in a risk register, and then you can start thinking about the treatment of those risks. So basically the mitigation measures that de-risk your project. And then when you've done this and implemented this is not the end of it. Then you need to basically always update and review your risk register and see, okay, how has this the mitigation measure worked with the risk? Has it materialized? Has it have been modifications done to it because the operations showed that this and that works better? And then there's continuous process, obviously, mentioned that before, then for further drilling campaigns that needs to be implemented, updated, and there is always further improvement possible if you're constantly working on that. A common mistake is that we've seen in the industry actually quite a lot is that you do this once at the beginning of the project and then nobody looked at it at the end of the project again. And then a lot of information is lost. And a lot of failures could have been prevented if you would have continuously worked on a risk register and the mitigation measures monitored. And again, here also the clear recommendation to have peer review processes included in this. So when you go from certain planning steps, for instance, when the drilling program is done, you do a peer review with an independent consultant and identify how consistent is it. Do we have blind spots somewhere? And that typically also strengthens the overall decision-making process in the company, and is a very good tool to use. When we're talking about the risk management cycle, this is also company dependent. It's a complex thing here. I will focus on a few points here, starting on the top of this graph with the company risk policy. That might be completely different when you are applying this risk scheme in an experienced E&P company. They might have a completely different view on the willingness to accept risks compared to a first mover in a greenfield area that is maybe only a municipality that wants to do something there in terms of their decarbonization plan. So it is important to understand from the beginning what is basically the willingness of accepting risks. And that obviously is then reflected in the overall risk assessment. Again, it is super important that an interdisciplinary team looks at the risk identification to not miss anything. And it also is also recommended to keep that team as constant as possible, because when you look at from different angles on this in a constant way, then that basically improves the overall quality of that risk assessment. When you have put your risk basically in different categories, I will come to that in a minute, you end up in a risk register and an associated risk matrix that we see here at the left bottom part of this graph. How this is work and how what's done there, I come to that in a minute. But then after that, you basically have still the option to mitigate your risks, obviously. You can simply reduce it by having certain decisions and better understanding and management of those risks. You can transfer risks, and this is where the insurance companies come in, or certain contractual arrangements with contractors can come in so that you can share the risks. But what is super important to understand is at the end, there is always a residual risk that remains with the operator. And that is sometimes forgotten when you look at interesting contractual agreements and everybody has the feeling, okay, we have shifted all risks to contractors, insurances, and so whatsoever. No, there will be a lot of risks still associated with the project that nobody will take except the project initiator. And that is important to understand. And you can control and validate those risks, obviously, by proper risk management. But in order to do that, you need to have that cycle in place. So how does this look like when you have a risk matrix? This is typically impact versus probability. And Why is this good to visualize? Actually, is because it clearly shows you where are the areas of that you need to focus on. There might be risks, just summing up here, in the low to medium area that might not need direct attention, and you can also maybe potentially save on those mitigation measures. But there are certainly areas where you have where you end up in the reds and orange or yellow sections that definitely needs attention. And that is something where you can then base your decision making on. Okay, let's focus first on those high risks, and then see what is still compatible with the rest of the project. So the mitigation then typically should transfer those risks that are in the high risk area to the low risk area. Kind of clear. You implement further engineering tasks or certain different technologies that you want to apply to reach that mitigation. And you can use those kind of updated risk matrices then also for very good communication and internal decision-making processes. And what you can also infer out of this is obviously the resource allocation. So some of the risks that are identified need further attention, and how can you do that? For instance, when it's a more communication issue, then you might need 1 or 2 more people in the PR department to deal with that. Or you need technical measures to deal with that. So it's also a very good tool to identify proper resources. Just a quick one, it's also important, this visualization helps also with risk mapping. When you associate that with certain cost factors, you can quickly come up with those risks that are actually have a big cost impact. And that might also need a certain attention then from the finance department. But in the end, you also want to come up with the outcome of a risk assessment that basically influence your overall budget of the project. So looking at that from an investment point of view, you come up with an investment budget or capex budget for your drilling campaign, for instance. And apply certain contingencies on top of it, because you have some probability analysis done via your risk assessment of what's the probability of certain risks that might materialize, and then you end up with a capex that is somehow between P50 and P90 to cover that, and then there might be additional requirements coming based on your funding structure. So if that is an equity fund investment structure, they might want to have some additional security here and there to stay in their in a certain mandate. There might be banks involved in the end, and typically banks are those companies that do not like the word risk at all. So there might be an additional contingency or management reserve needed to basically stay within the overall budget. And if then your business case still flies, then you have a very good secured project because you have thought about all those risks that could appear. You have put a number to it, and you constantly monitor it, and then you have a good chance to stay in your overall budget. So we have talked now a lot about risks, but there are also opportunities that you should not forget in this process. It goes both ways. In a risk management process, there are also the opportunities or chances reflected. And that is also sometimes forgotten, because you could either have the option to drill faster than planned, or certain outcomes are better than expected. So this is obviously also an important consideration, especially when you talk about contingencies and certain financial impacts. And what's also important when you talk about the financing of projects, the bankable or refining scenarios will most likely not be applicable for the first drilling phase, because there you have the highest risk, obviously. But later on, if you have a proper risk management in place, that could also help significantly with convincing those kind of institutions for, okay, we have done the first de-risking measures and they have worked, and therefore we can restructure our financing a little bit earlier than typically planned. Another thing that we touch on is also the portfolio approach. If you have certain bigger fields to develop and you partner up like it is done since decades also in oil and gas via partnerships and joint ventures, you obviously have a good option to share the risks with 2 or 3 partners. You can also diversify the risks overall with multiple projects in maybe also different geographies or different areas. And then you will also have the benefit of the economics of scale that goes along with that approach. So to sum this up, we have talked about the motivation and definitely the approach to ramp up geothermal energy in the energy transition, and we've seen a lot of effort and a lot of developments in this area. But we also seen the clear demand of standardized risks and uncertainty assessments or risk management. That's mainly driven by the funding, insurance, and subsidy regime. So we want to select economic projects, the most de-risked projects, and bring them also into an insurable or bankable state. And that can only be done with that structured approach. The de-risking of this project also only works if you have a good analysis of your risks and how you can mitigate certain risks, and that comes along with additional data acquisition, additional peer reviews to step out of the own bubble and get input from a third party. And we obviously want to reduce costs, so increase the learning curve, the implementation of all the learnings. And that is a direct input feed basically into a risk management circle through all the project stages. So from the early planning phase to the operation and drilling phase. And then in the end, we can further basically share risks via portfolio management or diversifying via multiple projects. That is obviously an additional measure to reduce overall risks. So that was in a nutshell. Yeah, that brings me to the end of that part of the presentation.
Thank you, Sebastian. Really on time is 11:45. Just maybe 2 burning questions to you before I give the floor to the other panelists. You can see the question in the tool. So first question, how do you assess the general prospect and potential of petrothermal projects in Europe and especially in Germany?
Yeah, as I said in the beginning, you can use those guidelines for petrothermal as well as for hydrothermal projects. Basically, a different emphasis on the risks that are associated with those projects. Obviously, that's why I, for instance, mentioned the seismic hazard studies that are very important for petrothermal projects, for instance, because that comes with the nature of that system that you might have to deal with that in way more intensity than hydrothermal systems. And a lot of also other techniques are developed, like closed loop systems that sometimes people also associate with petrothermal. It's a different approach, obviously, because it's a closed system, and quite different from the standard petrothermal open system. But it is from the guideline point of view, you can treat that exactly the same. You just need to have emphasis on different aspects, like one I already pointed out, and for instance, the permeability and the of the reservoir is something that needs to be assessed completely different, but could be integrated in that overall risk cycle as much as any other drilling operation.
Thank you, Sebastian. I see that it stimulated other ones to ask question. Maybe let's keep this question for later, because this one was really for the German guideline. The one are more general to the kind of different distinction and oil and gas. So maybe let's move from Germany to France, Virginie, and we gave you the floor to hear about what you have done in France about guidelines and standards for deep geothermal.
Yes, thanks, Philippe. Just to say a word for what I hear before, it's only remind me the GeoRisk project we worked few years ago only, and we work also on a risk assessment tool. So I think the initiative is already in link with what we have worked some years ago. And so more from French side, from BRGM, the main initiative was the development of good practice guidelines. That what is initiated in 2015. And this work was done on behalf of the technical committee of the Aquifer, which work on geothermal energy projects, and that brings together French public and also private organizations that are involved in deep geothermal projects. So the initial aim of this guide was to provide a recommendation of the construction of deep boreholes, geothermal boreholes, based mainly on feedbacks from the past years. But as you know, in the Paris basin, the main targeted reservoir is the Dogger limestone aquifer. And since 2007, there was a relaunch of many geothermal boreholes, and namely thanks to the heat front. So we have now a lot of feedback of deep drilling. So it was for this reason that we wanted to propose some guidelines. Those guidelines are also, the aim is to propose some state-of-the-art best practices, but also to propose some indicators to assess the quality of the different work and also possible improvements. And also to provide some new insight about the different new technology, new equipment, or new materials that are developed. For example, we have new well architectures that have been developed, also new materials that are used as fiberglass instead of casing. Sorry, I see casing. Sorry for I see. I don't find in English at this moment. So new materials have been developed, and we wanted to propose some fact sheets about different subjects. So it covers best practices mainly on drilling, on casings, on cementing, on deviations, on completion, logging, development, and testing, and operation. All these sheets have been presented to organizations and companies in the sector of the profession for approval. So it was shared to the profession. Actually, this guide was initiated, as I said, in 2015. It was during the time it was updated in 2021, and this year there will be a general update of the guides. So we had, because there are more feedback that can be included. So we have updated the most of the different technical sheets, and a new version will be available beginning of this year. Alors, it's in French, but we will, it was also done for the initial guide, we will do a translation also in English. So that's a part of the work we have done. And as I mentioned, it was mainly based on feedback on the Dogger aquifer, but we have also some feedback on a more sandy aquifer like Albion. that are also developed in the Paris basin, and now we also coming feedback from other basins, notably from the Aquitaine basin also, that where the geothermal energy also develop. We are also working, and this guide is also used, what I wanted to say, it's used by the profession, by the operators, but it's also used by the guarantee front, the French guarantee front, for the to grant, to cover the risk insurance, to cover all the projects for short time and also long-term risks. So operator must follow this guide if they want to be covered by the guarantee fund, French guarantee fund. So it's what we mainly work on. We are also as you know, we have in French we have developed a new, sort of new guarantee fund, because before it was mainly on the Île-de-France region. Now it's extending on the different specifications are extending on all the French territory. And this guarantee fund is now also segmented depending on the risk of the exploration. Because, for example, in Paris Basin, the geographic feature, the risk is lower. There can be some risk. We have already, even in Dogger, some failure of some well, but mainly for other basins where there are few geothermal well or only hydrocarbon well. They have defined some segments and probability table. We are defining some table of risk to define which, if the risk is greater, so the condition for the granting will be different according to the different segments. So that's also a work BRGM is working on with the different professionals. I think it's a bit what we are working on today.
Thank you, Virginie. And indeed, it's great to hear that after a first update in 2021, and I can also mention in the link that in the 2021 version, it's also available in English, so it's not only a French version, it's also in, and you're now doing an update. And great to hear also that you try to link the standard with funding instrument. And here's a question maybe for the audience later and for the panelists. No, Sebastian, you mentioned now the Bad-Württemberg area. Now we are working on, Virginie was mentioned between the difference between indeed brownfield and greenfield. The risk approach is maybe different, so maybe it's a topic how the standard can help both development. In the German guideline in December 2025, you can see as a source of information, of course, the French guide, but also some activities in Netherlands, and it's why I'm giving the floor now to Frank to hear. Okay. I remember 10 years ago, nearly, in Netherlands and especially the Dutch Association started to think about guidelines for well integrity. So please tell us more what you have developed in the last years.
Let's see. Can you all hear me? I guess so, right?
Confirm.
Okay, thank you very much for the introduction, Philippe. And also thank you, Ingo, Sebastian, and others for their presentation. Indeed, I work at Geothermie Nederland, which is the association for geothermal operators and suppliers in the Netherlands. I work there since 2022, but the Geothermal Association goes back a little bit further. In 2021, they merged, two organizations merged. And in 2021, there was also some concerns by the Dutch regulator that the initial wells that were developed in the Netherlands in 2005, 2006, those wells were were developed with lower quality carbon steel in the wells, and there were some concerns about leakage, and that indeed led at a certain point in 2021 to the development of an industry standard for durable well design. So that standard has actually been developed and has been adopted by all Dutch geothermal operators. So it is there. It goes into several technical stuff. I will not go into it. Maybe I can share it in the future. I have to discuss that. But it is a standard that has been developed together with the sector, but also with EBN. I do not know if you know EBN, which is the Dutch organization from the government side who take part in geothermal projects, but also in petrochemical, in oil and gas projects. So that standard has been developed to reduce risks of leakage and, well, to cover certain water-bearing layers so that they cannot be contaminated in case of leakage, and also with all kinds of standards of monitoring the well. And so that is I think the main standard that has been developed and that has been adopted by Dutch geothermal operators. Another standard that has been developed is a standard on norm naturally occurring radioactive minerals. When you're doing geothermal, you're producing water, but that water has some naturally radioactive occurring minerals in it, and those precipitate on the equipment and in the filters that you use to filter your sand out. And there is also some procedures in there to prevent contamination of the area. And so we have developed a standard in that has also been adopted by all operators. And another reason for doing that is that we want to standardize the way of collecting data from these operations, so that we can better assess the future load on getting rid of these light radioactive materials, because, well, you obviously need to dispose of these, and the rules in the Netherlands are pretty strict, as I understand, a little bit stricter than they are within Europe. So you need to dispose of them in a certain way, and, well, you need to have multiple paths in which you can dispose them, and we currently have only one path. So that is something that we have developed a standard for. I also really enjoyed the lecture by Sebastian on risk management. I have seen some stuff on this being developed within the community, also by EBN, and I think those things need to be. Now, I think they might become standards within the Dutch geothermal community, but that still remains to be seen. I've also seen something on cementing, a practice on that, also something that we might want to introduce into the community and see if the operators are willing to adhere to this, to do all these things in the same way, because that is obviously something that the sector can profit from. Another thing is, well, we as an association, we organize workshops and sessions where operators can really learn from each other, from practices that they have in their projects. And I think that is very important, because lessons need to be learned, and it's a little bit of a buzzword, lessons learned, and often these are just not learned. So what we're trying to do is organize workshops and actually capture these lessons and store them somewhere so that they can be read afterwards, and that the lessons can actually be learned. So in October, we organized a workshop with several operators who gave presentations on the the projects that they did in the last 5 years, and had some lessons learned. I actually had a presentation for that, but I think that's a little bit too much for now. So yeah, that's what we're doing in the Netherlands. The Netherlands obviously being a little bit different from other parts in Europe, because we have such a vast number of data from our oil and gas wells, and that also goes into the projects and de-risks a lot. But I think there's a lot of potential to learn from each other, and I just wonder to what extent that is being done throughout Europe. And yeah, I visited my first geothermal congress last year, and I will go to Offenburg this year. So I'm really looking forward to seeing how we can all learn a lot more from each other, because I think that is key to geothermal success in Europe. That's it from me.
Thank you, Frank. And you mentioned Offenburg. It reminds me something, because maybe some of you will leave after that. In Offenburg, Friday, late morning, we organize a workshop on standard and guidelines for geothermal. If you have not seen that, feel free to reach out to us. It's on our website, but I will share more information when I conclude the meeting. But feel free to go to this workshop. It's free and it's open to all of you. Indeed, as you mentioned, Frank, we need to meet and to discuss how we can move forward all these activities. Now we continue our tour of Europe, and we fly to Austria to give the floor to Gregor to hear more. We see some development of geothermal projects in Austria, so let's hear more how they are organizing themselves.
Yeah, thanks, Philippe. Thank you for inviting me, and also thanks to the previous speaker. It was very interesting. So I will talk on behalf of the Austrian Geothermal Association. Just to mention in advance, we would like to have modern standards in Austria. We don't have them yet. But what is very interesting and is that the current Austrian government is aiming to create a risk mitigation scheme for Austria. It's part of the governmental agreement, and I think there is a certain window of opportunity in the upcoming months that something will be created. Apart from this, Austria is still lagging behind in modern legislation for permitting and licensing. That's another big construction site. And the Austrian Geothermal Association is not directly involved into this risk mitigation scheme drafting, but we are currently preparing a kind of a position paper, a strategy, how this could look like, where also standardization is, of course, very important. So we hope we will step into this drafting process as a stakeholder in the near future. So how, let's start other way around. So how could this risk mitigation scheme work in Austria? So first of all, I just want to bring you some historical numbers. So in Austria, we have around 10 projects producing geothermal energy, most of them heat, some of them also electricity. Most of these projects are used for district heating. So this is the historical development starting in the late 1970s. So Austria has been one of the pioneers in Central Europe with geothermal district heating. But and that's the important point. These historic activities are limited to just 2 regions in Austria, covering a few, let's say, 10 to hundreds of square kilometers. And we have way more potential out of this region, where we could see as either greenfield or poor data areas, where, of course, in the past decades, oil and gas exploration took place partly. And what we see as a role model also for Austria is the current development in Germany, as mentioned in the beginning. So we would also like to see a kind of a streamlining of licensing in Austria, a risk mitigation scheme which could either be on a public or private initiatives or public-private partnerships, and investments into greenfield development. Austria had an investment fund started in 2024 on greenfield exploration, but this was cancelled after 1 year due to budget restrictions. That's a big problem, because we are facing this stop and go policy right now in Austria. I also think that the BVEG guidelines and schemes are a good starting point, which could also be applied to the Austrian situation. What I see very critical, and so I did some calculations on projects I know which are in the pipeline, that it's hard to reach thresholds that a private risk mitigation scheme could really be achieved. The problem above all is the lack of offset wells, which demonstrated the reservoir in full and demonstrated also the productivity. I think there are a lot of projects right now in Austria in the pipeline. Some of them also initiated by this Greenfield Development Fund, which was set up in 2024 and cancelled 1 year later. So we did some estimations about what can we expect in the next 5 to 25 years, and created 3 scenarios. So let's say the realistic scenario could lead to 10 to 15 new doublets and between 2030 and 2035, and up to 45 new doublets in 2050. What does it mean in terms of energy? So our development pathway, which varies between, let's say, I'm quite sure that we will hit the 1 terawatt hour, let's say, wall by 2030. Right now in Austria, we are around 0.3 terawatt hours. And depending on the development path, we could see developments up to 4 terawatt hours by 2035 and 7 terawatt hours by 2050, which could be quite a lot, because considering the size of Austria, which is significantly smaller than Germany, for instance. But this only works if we have the right, let's say, mitigation and licensing schemes. Yeah, that's what we are currently working on, and hope I can report some progress in the upcoming months. And by the way, I will also be at the Geothermie in Offenburg if you want to have bilateral talks. That's from my side in brief, and I give the word back to you, Philippe.
Thank you, Gregor. We have a lot of questions. We'll have also time for giving the floor to the audience, but I just want to ask the panelists, Ingo, Nicole, Sebastian, Frank, Virginie, do you have a reaction about what we just heard, or do you prefer us to give the floor to the audience?
I prefer to give the floor to the audience.
Okay, yeah, thank you, Frank. From your side, I saw that you already started to type some answers in many questions we have. So I will try to do by order. And the first one, it was to you, Ingo, Nicole, and Sebastian, regarding the German guidelines. So one intervener thinks that there's the distinction between risk and uncertainties is lacking in your guideline. Can you please react to the distinction between risk and uncertainties?
Yeah, I think it's not lacking. It is important to understand the difference, obviously, because we deal with certain risks that you can specifically point out. For instance, for the geological part, the risk of having sufficient permeability or the flow rate basically is one of the prominent ones. So that is the risk. And the uncertainty that comes with it is basically the scenarios that you have to look at to deal with that risk. So there might be a P10, a P50, or a P90 value, a probability that you hit a certain permeability or flow rate. And that uncertainty is basically the envelope or the framework you have to work with. And does this fit into your business case in the end? So that's one example. Could also be on the technical side, could be choosing a specific technology and have uncertainties that come with that. So that's the important thing. I hope it is explained in the guidelines so that you can infer that what I just explained again.
Mm-hmm. To continue on the German guidelines, and after I give a floor to the ones, one also question is that I do not see compression and stimulation as part of these guidelines. Will this be part of a future update effort? Compression and stimulation.
Yes, that is indeed, or let me rephrase it like this. We have specifically decided to basically deal with the execution part of the geothermal project on a high level, because it is important to introduce basically those measures that we have discussed, those techniques, those tools that you can use to assess certain stages in the project. And we specifically decided against going into very much detail of specific technical approaches, because they might not apply to all projects, or they have very specific setups in the project. So when we talk about stimulation and or production enhancement or whatsoever, that can be very specific, for instance. But you can apply those tools and those measures that we suggest in the guideline, obviously, to all project phases. And that is basically our high-level view on those topics. So there is no specific technology or specific project phase picked out, but this is done on purpose to basically give an overall applicability of the guideline.
Yeah. If I may add, absolutely right. When we developed it, we discussed for quite some time, well, what exactly do we want to put in here? And one of the ideas was to talk about specific risks, to talk about drilling risks, lost circulation, things like that, right? But those things, first of all, they're very complex and they don't fit into a kind of document that we were envisioned. And on the other hand, they already exist. So we looked rather into how do we approach the whole thing. So how do we deal with a stage gate process? We introduced the risk register. So it's and that makes it more general, and that makes it also applicable to things like stimulation, etc., with certain specific, slightly different approaches, maybe.
Thank you. Gregor, I know that you have some time constraints, so I give the floor now to you. There's a question that applies to you, but also I think to Frank, Virginie, and of course, Sebastian, Ingo, and Nicole, you're free to intervene. It was referred, I think, at some point by Virginie. You, Gregor, you mentioned licensing. How you think a guideline like the German, the French, the Dutch guideline should be linked with regulated domains or licensing application? We have seen that Virginie mentioned that the guideline in France is also linked with a risk insurance. How do you see this link between having a standard but also some regulatory constraints and link?
So licensing, I mean, is mostly about assessing the impact on, let's say, on environment, so risks, environmental risks, like induced seismicity, for instance, or the impact on existing other uses, competition of use. So for Austria, we have, let's say, two directions, two development axis. First is streamlining of the existing legal framework, which is very much focusing on the extraction and injection of water as such. It's not appropriate, in my opinion, for modern geothermal. And second is about claims, about concession systems. Both it's quite difficult. And for me, I would just refer now to the concession systems claims. I think what would be very helpful in the development process is also about a joint standard on defining a claim. So how do I define? It's about impact in the end. How much energy do I extract? Where do I outline my claim? I personally have not worked so much in that topic because it's currently off the table in Austria, but it's something I will certainly would like to exchange more in the future once I see there is a chance that also concession systems might be developed in Austria too. Thanks.
Thank you. Yeah. Any reaction?
I may have a comment. In the Netherlands, we are also really looking into licensing and insurances, and we as an association, we're trying to arrange a guarantee system in case some sort of damage happens, because there's a big trauma in the Netherlands from oil and gas extraction in the north of the Netherlands, and this might be incorporated into future projects. We are trying to develop that because that might ease some of the issues that we encounter into developing projects, actually. So that is something that is in development. Obviously, we have also a lot of developing rules and regulations on what temperatures you can re-inject, microseismicity, all these issues that I heard about in the last geothermal congress that I visited. It all seems to be all over Europe. The same issues seem to apply, and I think that there's there's really something that we can learn here from each other. And I don't know to what extent that is being done, and that's a pity.
We hope will be done more in the future. We do our best as EGEC and with you as member to do that, but hopefully we'll have a support from the European Commission on having established this geothermal alliance, which will also allow us to have a dialogue with the permitting agencies. Virginie, I come to you. I don't know if you have a reaction, but there's a specific question to you. Is that are the French overseas territories included in the scope covered by the geothermal guidelines?
Actually not. The guidelines covers operation for heat production, and what outside mainland France, we have for electrical plants, we have only two real operation in Guadeloupe and Alsace. So for this particular plants for electricity production, we have not developed specific guidelines at this moment. It's really the main target is for heat production. The guide.
Thank you. Also for you, Virginie, it was you referring to the insurance, and I think there's a confusion, so maybe I just clarify, and after I give you the floor. The insurance you are referring to in front is regarding the resource risk, no, to have a temperature and the flow. It is not the risk of a blowout or environmental risk. Huh? But the question is how you. I just come back to the question. It was from oil and gas. Is that indeed which aspect of a geothermal project are insured? In oil and gas, typically only insure against blowout, which is mandatory in many areas. So, what are the different insurance required regarding the risk associated with drilling? You know, Virginie, you can maybe start for France, and after Sebastian or can for Germany.
Insurance for drilling, you mean? What's
yes,
kind of?
Yes.
But they are specific insurance linked to the drilling process. That's a kind of insurance, and then they have the insurance linked to the guarantee fund, which is other kind of insurance, which will cover some specific. If for example, if it is linked to a failure due to because the state of the art was not followed, the guarantee fund will not cover the failure. But if, for example, there is a risk which is more linked to the geological risk, in this case, it will be more the guarantee fund that can cover the difficulty that was encountered. So it depends what kind of it's more technical or more linked to geological risk.
Thank you, Virginie. Sebastian, I think you wanted also to react.
Yeah, Indeed, when I mentioned insurances, there are a couple of insurance solutions on the market available for the drilling risk itself. These are risks that you basically have to drill a sidetrack, and that those costs could be covered via an insurance. But on top of the technical risks that you can insure, you can also insure now again the exploration risk itself. So having the risk of a dry well or not sufficient producing well, that is something that you can insure, and enable to do that. Obviously, you need to have a proper project documentation, all the basis for the analysis on how you come to the conclusion that a certain risk can appear or cannot appear, or has a certain probability to materialize. That obviously can only be done via following standard approach and having a proper risk management processes in place. And this is what the insurance and investor regime will look into way more intense than it has done this in the past, and that's why I mentioned that a couple of times. Those two guidelines that we have here in hand now will most likely be an important basis to judge is this specific project or this specific insurance solution a suitable one for that specific project, and then they will look into the quality of that documentation that goes along with that.
Thank you.
If I may,
Yes, Ingo.
if I may briefly add, and another one is an insurance against environmental impact for the neighborhood.
Sure.
Actually, in Germany, since lately, this is even legally binding that you have that. And there's different ways how you can do that in Germany structurally.
Thank you. I see some question to you also, Frank, regarding, I think if you share now, they want to have a link with your paper on the norm regulation, but the question to you is
Yes.
About mercury.
Yes. I just answered it, but indeed, I know that mercury can be part of the water that is being produced, but I think the concentrations are so low that they are falling below limits that need to be reported. But I do know that there is significant looking into this by the Dutch State Supervision of Mines, also in the oil and gas sector, because it is something that in the European guidelines, ECHA and REACH, it's a material of big concern, and that's why there's additional attention on it. But we do not have an issue with it in terms of geothermal, luckily.
Okay, after it's a question to the German colleagues, but I think also France and Netherlands you can answer. Is that you mentioned some errors, mistake, failure. Do we have a good database and do you have a reporting of these error mistakes? I remember some years ago we were thinking of having a database of incidents also to see what could be the lessons learned. Do you have such a material?
You're asking me?
You, Frank, and after Virginie, Sebastian.
Within our organization, we have indeed developed a lessons learned, a database on incidents. Indeed, we have done something, and it's being used by all operators, and they share their incidents. Obviously, they probably also have their own systems, but like in the oil and gas industry, we have something that covers all operators, and they all share some of their incidents in there, and they can review that for different stages of the geothermal process, and I think that's a good thing. It's also something that was promoted by Dutch State Supervision of Mines. So we have something like that. We developed that, but it is only the operators can go in there. So that's because there can be sensitive stuff in there. So
for sure, it links to another question about data availability, but we come back after that. Virginie.
Yes, in France, we developed database, but it's more about collecting data from geothermal well after drilling. So if there are failure upon drilling or after exploitation, it's not really the aim of the database to collect the reason of the failure. It's more to collect data, production data, geochemical data, but this database can help to understand why there was a failure, if it's linked more to geological. But it's not really the aim of the database for failure, to collect. What I understand of the question is more, is there somewhere we do a feedback of the different failure of the different projects. It was partially done when we do the good practice guide, because we have at BRGM we also do some expertise when there is, for example, a failure in a geothermal operation, or also when there's no failure, just to see if all was done in the state of the art. So we have some feedback of what was done, and when there was failure, the reason also of the failure. But there is not really a space to where we summarize all the failures, and that is public of the question.
Okay, and what about the German guidelines? Do you have in annex such a reporting of errors and mistakes?
We don't have a database on drilling incidents or something like that. But what we do have is a list of learning cases in terms of work safety. And that's, by the way, public. So you can go to our website and have a look, and the aim is we all want to work safely, and we want to share the learnings, right?
Maybe if I could add, I think that is a very important and also delicate question, because who likes to talk about mistakes? And that is something we need to have a kind of a rethinking here, because it is important to share those learnings. If we do not share that, nobody has the chance to learn from it. And that is something easily said, but hard to implement in the industry. It is something that is way better implemented in oil and gas, I have to say, because there the operator talk to each other and have certain ways of communicating, not all mistakes, but at least technical challenges that are known in certain fields. And we need to come to that in the geothermal space as well, because I see that too much in practice, that we redo all the mistakes that somebody has done 5 years before. And that is just a waste of money. And this is really, really avoidable in a lot of cases. And for that, we need to open up basically the community and saying it is good to share those mistakes. Nobody should get blamed for it, but you should actually get rewarded for it to share those experiences. But it is a delicate matter, and we need to find ways on how we better exchange that kind of information.
I couldn't agree more, Sebastian. I think that there's really a world to win there. Absolutely.
Absolutely. Yeah.
I think it was the reasoning of this webinar today, no? To not end the discussion, but to start further discussion. A lot has been done already. You can see, no, lessons learned has been reported, standard has been drafted, guidelines have been produced. In countries we mentioned today, I see from the audience reference to the AIDC, no, guidelines released last year. It's why we initiated today the discussion, but further will be done. For us as EGEC, the webinar today is part of a large initiative we want to launch on, in general, simplify permitting and have better projects. All over the year, but also in the next years, we will continue this work. The work started already partially last year with the first meeting of an EGEC task force on standard is to listen to you. What are the existing good standards to replicate and what is missing, because probably some things are missing. You could see that we work on deep geothermal, but we work also on shallow geothermal, and indeed also during the meeting in Offenburg, we'll look at the eco design regulations for heat pumps. We cannot answer all the questions. There are many questions. If panelists are fine, I will send you by email, and maybe we can have some answer by email as a follow-up. I invite you again, if you're in Offenburg, to meet us in this task force meeting on Friday morning. My colleague Giulia Cittadini is in charge of registration, so feel free to drop her an email. It's time to conclude, to give a big thank you to all the presenters. Thank you indeed for this really great webinar. We had 600 people registered. We had more than 400 people attending at a different moment. A lot of questions, not all, we were not able to answer all of them, so a lot of interest about the topic. So thank you, Ingo, Nicole, Sebastian, Virginie, Frank, and Gregor for this really great webinar. Thank you all for having participated to this webinar, and I wish you a good end of the day and hope to see you soon. Bye-bye.
Thank you.
Thanks. Bye.